Hello everyone. In this course, I'm going to introduce ANSYS Design Modeler and we will go into very details about each and every command, and then at the end of the course I will be solving the full-fledged workshops which are very complicated and they represent the real-world problems. And my name is Sajjad Ahmed Memon. I'm your course instructor. And the course contents are these ones. So first I will introduce the CFD process and what is the pre-processing and the graphical user interface of Workbench and Design Modeler. Why? Because we can only use the Design Modeler inside the Workbench. So that's why knowing the Workbench is also necessary. And then the first thing is that I will be discussing is how to set up your first project in Workbench and Design Modeler. And then I will go through some basics such as the name selection or boundary conditions, bodies and parts in Design Modeler, and what's the difference between the bodies and parts. And also I will correlate them with the geometry features. And then I will tell you about the freeze and unfreeze and what is the meaning of frozen body and the operations we can apply and the benefits. And also I will discuss about the different modes of the geometry, that when it's suppressed or it is deleted or when it's hidden from the view. And then we will go through the geometry cleaning, and this is the main reason that the why Design Modeler was developed by the ANSYS, and also the fluid volume extraction, that is to create a domain around some external geometry or extraction of the fluid domain when you're talking about the internal flows. And then we will go through the geometry operations such as the Boolean operation like the subtract, add, and body transformation like the move, etc. And the pattern means that we can create the multiple parts from single part and we can pattern them in rectangular fashion or in circular fashion. And the body operations like the slice, etc. or sew, there are many operations. I'll discuss them one by one. And then I'll discuss about how to use the fillets, and there are different type of fillets like the fixed radius, variable radius, and the vertex blend. And the vertex blend is only used for filleting the vertices. All right. And then the chamfer, you know that this is like if the geometry feature is like this. So the round means that we apply some radius and it will make it round from some location. And chamfer means that it will add a straight line. And these features are necessary especially for stress management in any particular structure. And also I will go through these commands, concept modeling, and the concept modeling is basically discuss about the 2D modeling in ANSYS Design Modeler. So we can create 3D curve especially used for creating the aerofoil. So we can import the aerofoil coordinates and then it will automatically can create the aerofoil, or we can also manually create the aerofoil from the coordinates. We can create the surfaces from edges, we can create them from sketches, and the lines from points. And I will also discuss about the surface, face, edge, and line. So line and edge, they should be same, but it's different in Design Modeler, the way we treat them. And then we discuss about 3D features like extrude, revolve, sweep, skin, loft. And also we discuss about the primitive bodies like these are the well-defined shapes like slender, sphere, box. So we can use them without creating any sketch and then making the 3D commands like the extrude, revolve, and then get those features. So we can create these primitive bodies with a few clicks, and we can make them into our existing geometry. And also we can analyze the geometry like for the errors, and also this command is used for measuring the different dimensions of the geometry and geometry cleaning and other options. And then at the end of the course, towards the end of the course, I will discuss about the sketches and plans. So why I put the sketches and plans at the end? Although I will be discussing the plans time to time or sketches time to time, but the reason for putting the sketches and plans at the end, because this is related to creating a new geometry from scratch. Okay, creating new geometry. But the main purpose of Design Modeler or Space Claim, there are the three softwares: Space Claim, Design Modeler, and also they have now Discovery. So Design Modeler was the starting software, and Space Claim they acquired from the Space Claim company. And the Design Modeler was initially used for these all purposes, but now Space Claim is taking more attention because of its 3D direct features, like we can create the domain very easily, we can repair geometry very easily. But definitely the Space Claim lacks the sketching, although it does provide the sketching, but it does not provide the sketching as powerful as we have in Design Modeler. So that's why I put the creating new geometry from scratch at the end of this whole course. And then the tutorials are the small exercises will be following each and every lecture, where we have to clarify some concept. For example, if I'm going to give you the fixed radius fillet, then I will be giving some example and apply that thing on the particular real life example. Okay, but the workshops, these are the something that is like a full exercise that contains many commands from this whole course, and like making the whole aeroplane or making the whole domain and getting the fluid volume for the whole aircraft, and then making the symmetric models and then providing boundary conditions. So this will be like a workshop, and tutorials are small exercises. They are following the each and every command. Okay, so this is about introduction of the whole course. And so basically what we are going to do is that we will learn about ANSYS Design Modeler. And ANSYS Design Modeler is mini CAD modeler under Workbench. So this is different than the Space Claim. And also I told you that there is another option, that is the Discovery. The Discovery is basically it uses the Space Claim in the background for geometry. Although usually speaking, we assume that the geometry is already made in some CAD software. So we work on cleaning of geometry. We want to add or remove some features which are not important or which we want to introduce to the design. And more importantly, we have to create the fluid domain. And this can be also, similarly, we can also create the geometry model for the FEA. In that case also, Space Claim is very powerful. The Discovery is basically, it uses the Space Claim for geometry in the background, and it can create a very quick solution. So for quick solution without knowing anything at all about anything what is in the background, so without selecting any option, Discovery can give you very initial good results for your design. So for very quick simulations, the Discovery is the way to go. Okay, and so but the problem is that the Discovery or Space Claim we can use them separately from the outside the Workbench as well. But Design Modeler can only be used inside the Workbench, and it's a mini CAD modeler. And but from the Design Modeler you can export geometry in various formats, like the Parasolid, like you can export geometry in IGS. But the only thing is that you must have the license for importing or exporting geometries from Design Modeler. And so you can also import geometry. This is a very powerful feature that you can import them in many formats. Like you can import geometry in AutoCAD format, you can import geometry in CATIA, you can import geometry in many generic formats like the Parasolid, SAT, IGS. Okay, so the main question is that as the things are progressing at the very fast pace, so one may ask a question that why we want to use Design Modeler when we have the Discovery or Space Claim. So the thing is that the DM is not the same as a Space Claim. A Space Claim is basically is used for repairing your geometry and creating the fluid models for CFD or FEA models for the FEA software. But DMS basically gives you taste of the Minicat software. It follows the hierarchy of child and parent like you do in the CAD softwares. It has the sketches, planes, and on those planes you have the sketches, and then you can combine different sketches to create 3D feature, or you can directly use a one single sketch and you can just exclude the geometry. So this is Minicat software also, and also it has the very nice tools for repairing, cleaning geometry, adding the features or deleting features, and then the domain creation. That is the main theme of these softwares. And so basically what you get in the design modeler is that you can import many type of geometry formats into ANSYS for simulation. And you can also directly link design modeler with your preferred CAD software. For example, if you are working in the CATIA and CATIA model is open, then you just open the workbench and drag the design modeler into workbench. And once it is open, then you can directly attach the geometry from your CAD software to the design modeler with a single click. So there's no need to export geometry from your CAD software and then import geometry into design modeler, but just you have to link them. So link is also done automatically. So just click on the one command and that model from the CAD software will be transferred to design modeler. And you can also add or remove features like in some cases nuts or bolts, they are not needed for CFD simulation. They are maybe important for FEA, but for CFD simulation they are not important. So you can directly remove them from your CAD model. And then you can repair your geometry. You can repair sliver surfaces, extra edges, short edges, interfaces. You can remove extra edges such as holes or nuts, bolts. You can also repair the sharp angles. You can repair split edges. And then you can create your fluid domain around the geometry or extract the domain from the inside of some internal geometries. And you can also create the geometry from scratch like you do in any CAD software using sketching and the planes. And the geometry transfer is seamless and error-free within the ANSYS environment. So you work or you import geometry into the design modeler, and then you can, after making any changes or no changes at all, you can transfer to next module in the ANSYS. And there are some differences which are written here.